Hello, my name is Sean, and today I'll be going over Indigo Cipher. So to start off with, I'm just going to grab every screen here. RGEBAR, followed by FTREWCMJB. If I got that right. MJB, okay. Keyword of thud. And we got SF 11101 and 00010. Oh, 010. We got a key of 33, question mark 60 equals 34. Alright. To start off with, we're going to go with fractionated Morse cipher here. And in this cipher, we're going to take our keyword right here from the bottom screen of page 1 and turn it into a key. So first thing we're going to do is remove any duplicates from the key. There are no duplicates in the key. Then we're going to remove each letter occurrence in the alphabet. So T, H, U, and D. Then, if the number of ports is odd, which it is even, otherwise place the alphabet in front of the key. So this goes right there. And then, now that we have a letter key, we're going to place this underneath the key. And now, we're going to take our encrypted logic key, that's what this is, from the middle screen of page 1, and we're going to convert each character to a 3-character code from the key that we have here. So we gotta find F, and then we have to look under that F, dot, dash, dash. So this would be dot, dash, dash for F. Next, we gotta find T, that is an X, dash, dash. Next is R, finding R here is dash, X dot. E is dot dash dot. W is dot X dot dot. C is dot dot X. M is dash dot dash. J is dot X dash. That's J, and finally B is dot dot dash. And then we're going to convert these Morse characters, treating the X's as spaces in between the Morse characters here, and convert them back into letters. So we gotta find this here. So dot dash dash is a W. Next is dash dash dash, that's an O. Dot dot dash dot is an F. Dot 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 is an H. Dash dot dash dot is a C, and finally dash dot dot dash is an X-ray. Now, it is going to form 6 letters, but it won't form a word necessarily. It's just going to be a 6-letter logic key. If you didn't get 6 letters, then you obviously did something wrong. On to step 2, which is going to be Conde cipher. And for this particular one, all we got to do is use the same key that we used back in step 1 and replacing the bottom of it with this key instead. Now for each letter, starting with an offset equal to the sum of the serial number digits, which is going to be 5 plus 5 plus 2. That's going to be 12. We're going to go find R here. Find the letter of the encrypted word from the top screen of page 1, and we're going to find it in the key. And then we're going to go left a number of times equal to the offset. So this is going to be 16 minus 12 is going to be 4. The 4th letter in this key is going to be echo, so R translates to echo. And then the new offset becomes the position. And that cards that under E is a 4, and that becomes our new offset. Now we gotta find G here. G is over here. So that is going to be a key of 6. We're going to go 6 minus 4 is 2. 2 is B. And then 2 becomes our new offset. And then find echo here, which is right here. So this is 4. So echo, which is 4, minus 2 is 2, which turns into another Bravo. So and our offset becomes still a 2. Then we have Bravo here. So we've got to find Bravo here, and we're going left twice. Now when we do this, which is 2 minus 2 is 0, we're going to add it until it becomes a number between 1 and 26, adding 26. So 0 plus 26 becomes 26, obviously, and that's going to give us a D. And our new offset becomes 26 in this case. Then we also now have A here as our new thing, and we're going to go left 26. So 1 minus 26 would be negative 25. Then we have to add 26. So that'll be basically 1. That would be A in that case. And our new offset becomes 1. Then we find Romeo here, which is going to be 16 here. Minus 1 becomes 15. That is going to be a Quebec. And that is it. That is our new encrypted word. On to the final step of this cipher. We're not going to longer use this key, but there are some things that we're going to do in this case. So, now the next thing to do is logic cipher, in which we're going to figure out what this gate is using this equation that we have. First, we're going to convert all 3 of these numbers into 6-digit binary codes. And if you don't know 6-digit binary codes, then there's a chart over here on the next 2 pages that'll basically tell you how to convert these numbers. So we're going to do find 33. That is going to give us a number of 1, 0, 0, 0, 0, 1. Next is 60. 60 is going to be 1, 1, 1, 1, 0, 0. And finally, a result of 34, 1, 0, 0, 1, 0. No, 0, 1, 0. So, let's figure out this logic key by treating the left number as our left bits, the right number as our right bits, and the resulting number, which is this third number here, as our resulting bits. So, the first case is we have an input of 1 and 1. So I'm going to place that on the chart. So this is the left bit, right bit is a 1, 1, and the resulting bit is a 1. So then I'm going to go ahead and basically highlight any 1s. That means it's basically one of these possible gates. Now we have an input of 0, 1. So here we have 0, 1 here, and we got a result of 0. So I'm going to unhighlight any 1s because, you know, it can't be that. So it can either be AND, XOR, or left arrow. So it says 0, 1, 0, 1. Here's an input of 0 and 0. So input is 0, 0. And we're given an output of 1. So it can't be the AND here. Then finally, we have an input of 1 and 0. So 1 and 0 here. And we left an output of 0, which is not this one. So that means our gate is going to be XNOR. And that's all we needed that step for to be anyway. Now what we're going to do is convert each of these letters here into numbers. So we're going to turn the first letter of the encrypted word into its alphanumeric position. So -1. So echo is 5, -1 would be 4. Then turn the number into a 5-digit binary. So finding 4 onto 5 digits here would be 00100. 00100. Then, if the top screen binary bit at the same position as that letter is a 1, invert the bits, which the top screen is this one right here, and it is indeed a 1 at the same position as it is in the letter here. So we're going to invert all these bits. So this becomes 11011. And then we're going to do the same 3 steps for the logic key here, following using the bottom screen, or I mean the middle screen here as our bits instead of the top screen. So here we're going to convert W into a number here. So TUVW is 23 minus 1 is 22. Then convert 22 into a 5-digit binary. So here's 22. 5-digit binary of that is 10110. Then if the position of that letter of the binary bit there, which is this first bit, is a 1, which it isn't, so we don't have to do anything. Then we're going to apply the logic gate to these bits, treating the encrypted letter binary as our left bits and our our logic gate, our logic key as our binary bits as our right bits, more or less to say. So we're going to XOR both of these things. So basically 1 and 1 gives us a 1. 1 and 0 gives us a 0. 0 and 1 gives us a 0. 1 and 1 gives us a 1, and 1 and 0 gives us a 0. Then we're going to convert these binary bits back into a number. So we gotta find 1, which is right here, and then we need to find 101. That is going to be 18. And then we're going to add 1 to this, making it 19, and then convert this back into a letter, which basically turns into S. And S is going to be our first decrypted letter. All right, on to the next one. So B is going to be 2 minus 1 is 1. So this will convert into 00001. And then if it's a 1 here in the top screen, which it is, we're going to invert the bits. So that's 1, 2, 3, 4, 0. So this converts back into this. Then we have Oscar here, which is 15 minus 1 is 14. That gives a number of 0, 1, 1, 1, 0. The binary bit at that position is a 0, so we don't invert it. Then we're going to apply the logic gate of XNOR. So then basically 1 and 0 gives us a 0. 1 and 1 gives us a 1. 1 and 1 gives us a 1. 1 and 1 gives us a 1. And 0 and 0 also gives us a 1. Then we need to convert this back into a number. So 0, 1, 1, 1 gives us 15 plus 1 equals 16. The 16th letter is a P. All right, next we have a Bravo that is going to be a 2 minus 1 is 1. Then we convert that 1 into binary, so that's going to be 00001. Then let's see if the binary bit at that position is indeed a 1, so we got to invert the bits yet again. There we go. Then we have a Foxtrot. So Foxtrot, let's see here. Actually, let me move this up by a bit so that way I can see that much better. Foxtrot is a 6 minus 1 is 5. 5 would be coordinating to this. So that's going to be 00101. Now apply the gate. Well, then we check the bit here, which is indeed a 0, so we don't invert it. Then we apply the logic gate here. So 1 and 0 is a 0. 0, 1 and 0 is 0. 1 and 1 is a 1. 1 and 0 is a 0. 1, 0, 1 is also a 0. So this is going into 00100. That's right here. That's going to give us 4 plus 1 equals 5, which translates into an echo. All right, next we have delta. Delta is going to be a 4 minus 1 is 3. 3 is going to translate to 00011. Then we check if the top one is a 1, which it is a 1 in that position, so we got to invert the bit, so this goes into 11100. Next, we find hotel. Hotel is going to be So as 8 minus 1 is 7. 7 relates to this one, so 0, 0, 1, 1, 1. See if the bottom binary at the bit is a 1. No, it's not. So then we apply the logic gate. So 1 and 0 is a 0. 1 and 0 is a 0. 1 and 1 is a 1. 0 and 1 makes a 0, and 0 and 1 makes a 0. This is going to be 0, 0, 1, 0, 0. That is going to be a 4 plus 1 equals 5. So the next one is another E. Okay, next is alpha. Alpha is going to be 1. Minus 1 is going to be 0. 0 is going to contain 5 bits of 0, 0, 0, 0, 0. Check if the top bit of that position is 0, is a 1 I mean, which it is not, so we don't invert anything. Then we have Charlie as our bottom. Charlie is a 3 minus 1 is 2. 2 relates to this one over here, which is going to be 0, 0, 0, 1, 0. See if the bottom binary bit at that position is a 1, which indeed it is, so we got invert these bits instead. So that's going to be 1, 1, 1, 0, 1. And then all we got to do is apply the logic gate. So this is going to be 0, 1 makes a 0, 0, 1 makes 0, 0, 1, 0. And that is going to be 0, 0, 0, 1, 0. That's going to be 2 plus 1 equals 3, which turns into C. And finally, we have Quebec. Quebec, if I remember correctly, is 17 minus 1 is 16. 16 is going to refer to this. Check if the top binary bit at that position is a 1, which it is, so we're going to invert the bits, like so. Then our next one is X-ray. It's going to be 24 minus 1 is 23, which is going to be 1, 0, 1, 1, 1. Check if the bottom binary bit is a 1, which it isn't, so we don't have to invert those bits. Then apply the logic gate. So 0 and 1 is a 0, 1 and 0 is a 0, 1 and 1 is a 1, 1 and 1 is a 1, 1 and 1 is a 1. Then convert this back into a number, so that's 7. 7 plus 1 equals 8, and 8 is H. And that is going to give us the word, our decrypted word of speech. To enter the word, all we gotta do is start typing on the keyboard here. You can't go past 6 letters, and if you made a mistake, you can always clear it out by pressing one of these arrow keys here. So let me retype this back in. And that is a solved module. Hope all of you enjoyed this tutorial, guys. Until next time, keep talking and don't explode.